Alrighty, welcome to the authorization demo session. First up for today, we will have RSA. So, Michael.
Thank you, Nick. Appreciate it. My name is Mike Dalton. I'm an identity engineer for RSA, and we're going to be talking about how Secure ID Access can provide secure and convenient access to a wide variety of applications, whether they're on-premise or in the cloud, and how you get authorized to those applications. So if someone's out and they get a request to sign into Salesforce, you're working, you'd have to leave, go back to your hotel potentially, get on VPN, and get into Salesforce. If you could instead just provide approve, biometric, and say, I approve this transaction and get in, it saves that trip. This is the type of secure and convenient access that we're looking for. Likewise, if someone leaves the office and forgets their laptop behind, but has a tablet and they can get into different applications, if you can get into a portal or a central way to access applications, and then provide step-up authentication, whether it's biometric, push to approve, or RSA's hardware tokens, software tokens. These are all accepted ways to access applications. One of the important things that needs to be provided is if you're offline for any reason, if you don't have cell phone reception and you need to provide authentication, having the offline capabilities to go ahead and provide that approval is also something significant. You want that flexibility, and RSA provides each one of those. So I want to talk a little bit about identity assurance and how we can tie risk back to an application. So if my identity were compromised for any reason, it would be bad for me. But if someone that was head of HR for all of RSA was compromised, that'd be very bad for the company. So we want to provide a restriction on privileged access in particular and tie the risk back to the application. So we do this using a variety of different attributes, and we can add context and risk to the equation. So we can say, what do we know about this person? Are they on network? Are they off network? Do we have their IP address? Do we know their geolocation? These are different things that we can use to tie risk back to an application and say, this person, we're either highly confident that we know who they say they are, or we're not. And if we're not highly confident, we're going to issue a challenge. So we're going to say, if we don't know who you are, then we're going to do a push notification to your phone, and your phone, when you provide that biometric authentication or approval, it'll say, okay, now I understand that you have an authenticator associated with you, and you can proceed. So this is all part of identity assurance, so we can challenge according to the risk and provide the right level of visibility. So what does this look like in practice? In this example, let's see. There we go. Okay. In this example, I have application Salesforce. You can get into it, which is listed as a medium level security application. I go click on it. I get a prompt for multi-factor authentication. I have a SAML checker and Office 365, two different levels of security, three different levels. When I click on Salesforce, it'll go ahead and it'll do a push to my phone, and I can provide the levels that have been associated by the administrator to me. In this case, I have fingerprint authentication. But I could have FIDO tokens. I could have the RSA Secure ID tokens. So we can always fall back on the tokens no matter what. But we have convenient ways to authenticate beyond that. So as I mentioned, biometric authentication is one of them. And once I get that session and I prove that I am who I say I am, then I go back to this, the session. And if I go from medium to low, then if I already have a session, there's no reason to do an additional step-up authentication. If I'm already authorized at a medium level, I shouldn't have to do an additional challenge. So if I go to the SAML checker, I just get single sign-on, and I get into the application. So likewise, if I had a higher level application, like Office 365, if I access that application, I would get challenged because now I'm going from a medium level to a high level, and it requires additional authentication. So that's when you can use tokens if you want to. But really the place we want to get to is let's go beyond tokens. Let's go beyond the binary, off-on sort of setup for authentication and authorization. And I'm going to jump out of here for a moment. What if, go ahead.
Why would you use a FIDO token as opposed to an RSA token?
So, with FIDO, we have the capability of doing user self-registration. It could be an overseas call center where, you needed to get something where your end users could register quickly. So if you needed something that you could procure locally and then register it, that's something you could allow. Yep. So really, if we can get an idea of who someone is, we can say, based on static attributes, IP address, on-network, off-network, we may be able to provide access and have a high confidence level and just let someone into an application without actually issuing a step-up authentication challenge if we already know their current status. If it is a risky transaction, then we want to go ahead and provide that step-up authentication. And if it's not provided, we're just going to deny access. So what we saw firsthand at Black Hat, we're responsible for protecting the infrastructure at Black Hat. You'll see over time, authentication challenges went down, but authorizations continued. So the blue box there that talks about authorizations continued to go up. Let's say after 10 successful authentications, we're highly confident that you are who you say you are. We can provide that access without issuing a challenge, so it becomes frictionless authentication. You have secure and convenient access that still meets policies in probably one of the most hostile places for a laptop to be in the world, right? So it's something that we call identity assurance, and it's secure and convenient access. Any questions? Thank you for your time. There's also a conference at 1:30 to 2:30 where there's a panel for RSA will be talking as well.
Alrighty, thank you, Michael. And up next, we have Trueface.ai. So, Sean.
Hi, everyone. So I prepared a presentation, but I think I'm going to go into a demo pretty quickly. I'm Sean, the CEO of Trueface.ai, and we provide facial recognition services for both surveillance and know your client. This is something that I'm sure you're all very aware of. Cameras are everywhere. 2D cameras make up 99% of the infrastructure today, and the thing that 2D cameras are missing is scalable architecture that can run intelligent software and not be fooled. These are just some of the reference companies that are currently using facial recognition technology in a variety of different ways, from Disney using it to capture images, candid images of families while they're at their theme parks and then send them to them later as a try and upsell to one of their services. The global biometrics market, the reason this slide is up here is because it went from $14 billion 3 years ago to $60 billion. So you can see the significant increase in the potential of this technology across a variety of different industrial verticals. The facial recognition for surveillance, that went from $1 billion to almost $8 billion in 3 years. The reason why I'm here today is my journey with facial recognition began in 2012. We started researching biometrics, and specifically we witnessed the FBI change one of their databases from fingerprint scanning to facial recognition, and that was a little tip-off point in our head that said, if our governments have recognized a trend in identifying people and authenticating them, we should also. So in 2014, we were the first company ever to embed facial recognition technology locally in a doorbell. In 2016, we embedded that same technology in a commercial access control product. Now, what's very, very important to remember with facial recognition is that if I have any false positives or any margin of error for me holding up a picture or a video of someone else to gain access, that technology no longer works. Online, it doesn't matter as much if I'm tagging a friend in Facebook. It does matter as much if I'm opening a bank account or if I'm granting access to a building. And so in 2017, we spun our software component out and launched Trueface.ai. The progression of our technology is as follows. We are capturing a live feed, detecting a face first, identifying that face, turning that into 68 different landmarks, embedding that into what we call face embeddings, which is like your face fingerprint, 128 different proprietary dimensions that we create on your face. So it's completely different than the picture we captured to what we actually store. And then we run face matching, which is like your iPhone one-to-one matching, or face recognition, which is one-to-N. We are the only company in the world right now that can do spoof detection on 2D static images. What that means is if I hold up a picture or a video of someone, we take a single frame and can identify whether or not that's a real person or a picture or a video of a person. We've got 2 different deployments, localized deployments. As I mentioned, our history is in local and edge facial recognition, and then an open API for individuals that want to take our technology and implement it into their applications. This is a product that we built because there was a need for us to show how our technology worked. I'll be demoing this product in a second, but basically what happens is we scan your ID, we do OCR and document verification, we do then the proof of possession and proof of what's the word? Okay, well, you'll get to it. So it's to ensure that that you have that ID in hand or that you have that ID stored with your face. And then we run things like sanction checking and social scraping to verify that ID, that face, and the individual social profiles. Some of our competitive differentiation is, as I mentioned, spoof detection. We're the only company in the world that can do that with the 2D static image. For surveillance purposes and for access control purposes, we can take old video feeds or old infrastructure and enhance that, magnify that by up to 4 times. So if you've got let's say a hotel or an airport with 100 or so cameras, we can operate across all of those cameras and just improve via software the older infrastructure. In addition, we do dynamic false positive reduction, so we're actively training random sets of samples against the collection of those individuals. So you've got 1,000 employees, we're taking 3,000 randomized faces, and we're matching you to both the randomized faces and the employee set to see what you score closer to. The label faces in the wild, since I built this presentation, we actually score a 99.7 now, which is the highest performing mark on the label faces in the wild test. We recently tested our model on the Mega Face Challenge, which is 1 million faces, and scored above a 97%. That's 4% higher than the next one behind us. In addition, this is something that we're announcing today. It's brand new technology. It's adversarial attacks. What's happening here is there's a pixel overlay over George Bush, and the technology, the machine learning actually reads that as Barack Obama. So where this has a very gruesome implication is self-driving cars. So you've got a QR code, you've got a sticker, you can go place that on a stop sign. The technology of the car will actually read that as green light. So very, very much impactful when it comes to that. For facial recognition, where this is a big issue, is access control as well as not wanting to be seen. So if you're at an airport and you're wearing a pair of just regular glasses, you can put a little sticker on the glasses and the technology will read that as you are someone else walking through the airport. The same thing goes if you want to access a building or if you want to access a digital identity online. So this technology is going to be very, very, very important, and we're the first facial recognition company that has this technology now. Just an example of what we do in the security and surveillance sense. We can identify individuals that are sitting in lobby. We can identify 100 people in one frame. And so I'll get to this example as well. Another instance that we're seeing facial recognition being used with our technology is to verify and greet VIP guests. So as they get out of the car and they approach the hotel front door, we can identify them in real time and provide that information back to the concierge or back to the individual greeting them. And then access control, whether that be back office access control, enterprise access control, or even getting access to a car. This is the type of technology that is now being run at the edge, and we are able to verify individuals in real time, as I mentioned. So I will get to these demos now. So this is just an example of our facial recognition running in a surveillance environment. And what you'll see here in a second is this is actually one camera, and we just split the frames. You'll see my CTO walk up on the bottom left hand of the screen, and it verify him. What we're doing is we're only sending notifications to these individuals if it's above 99%. So we've got a group of people that we want to recognize here. Let's say it's 100 individuals we want to recognize in real time. And what we're doing is we're actually projecting the scores of those individuals and only notifying the appropriate entities if it is above a certain score. An unknown score is just as good as a known score because it means we're not going to have a false positive. So a 99% unknown score is actually a very good thing for us. And then this is part of our KYC solution. So we surface this KYC solution one of three ways. This is just through our dashboard, which you can white label and use yourself. We also have a widget, and then through our API. So it just depends on the infrastructure that you want to use for this. But it's very, very simple. You send it to the email address that you want to verify. And as mentioned, we do the web verification, the sanction list, and the document verification. For now, I'll just do the web and sanction list. So that will get sent. I've got my email. I get the code, verify. Oh, you don't have my IDs on your computer. It's not going to work. I can show you this after for anyone that wants to see. But what you go through and do, I can get you somewhat far. Then you would just upload the 2 images here, and then we actually, in about 12 seconds, will verify those documents are real. We'll verify that you didn't hold up a picture to that camera. The step after this is you take a selfie, and then we verify that. So we match the selfie with the ID pictures. We make sure the back of the IDs match the front of the IDs. We do OCR to make sure that information is correct, reference that to a database, and then the sanction checking and the social media scraping. Like I said, it's about 12 to 15 seconds, and then I, as the customer, have the results, and then whoever asked me to perform these has the results plus the images. So I know I'm running close on time here. I'm happy to answer any questions or show this later.
Sean, a quick question regarding the technical level of the cameras that are required to input the images. Smartphone devices, can they capture the images and you can have equal results?
Yes. So the only time we've seen a difficulty capturing results from a long distance away is with VGA cameras, 640 by 480. Everything else, we built the architecture itself to retrofit all IP cameras. So in terms of surveillance, and then the smartphone cameras are actually quite good. Mm-hmm.
How long does it usually take if you have to match one particular image to a database of, let's say, 10,000 images?
1 second. Actually, under a second.
Is it a pre-indexed database?
Yes.
And what's your magic formula?
I wish I could tell you.
Quick question, where is your technology deployed at this point? Can you tell us?
I can't. A couple of very large commercial properties. It's being deployed in airports, so for some of the governments, and then also KYC companies, online proctoring companies. It's a variety of different applications for it. Thank you.
Alrighty, thank you, Sean. And up next, we have Dispel.
Hey, good morning. My name's Ethan. I'm the CEO of Dispel, and we are a cybersecurity company that makes cloaked networks that can protect endpoints, APIs, and people. And so I want to start with this sort of slide, which is just a big number. Most security talks start with these kinds of big numbers, which is either the number of identities that have been stolen, the number of times that your SOC is getting hit by adversaries, any kind of environment where you're dealing with large, basically publicly internet exposed endpoints. And the sort of thing that most companies do is they then move on from this point, and they just discuss the security tools they can put in after the fact to deal with either detection or authentication later down the stream of that. And what we started with was the question is, well, why do these people even know where these networks are to begin with the principle that applying a military concept to a civilian market of if you don't know where those systems are at a given point in time, you're not going to be able to, as an unauthorized user, actually even begin the challenging program of either trying to authenticate yourself falsely or just brute force your way through using other kinds of cybersecurity breaches. And so what we do is we create these cloaked, virtually air-gapped enclaves that allow people over the public internet to be able to access secure, sensitive environments that they still need to be able to have remotely. And so some of the applications we've seen with this stuff is either in, the first one is sort of the junk drawer, right? Most institutions are dealing with older systems that either can't be patched or are outdated, so the Windows servers that are from 2003 that are still running. The question is, those are critical now parts of institutions. How do we protect them? How do we keep people from able to log into them where we maybe can't apply contemporary security protocols and authentication protocols onto them? One of the other areas is creating secure sandboxes. By using virtualization, we can actually create environments that people can test systems inside of and secure either data sets that authorization would otherwise let people into. And the final area are project-specific collaborations. So when you have teams that are working together on either outside parties that you have to communicate with, you don't want to bring them inside of your organization. Even if you can maybe sandbox them inside the network, the fact that you've told them where those systems are in and of itself gives people some insight into how your network is constructed and therefore creates a security risk. So we want to create an offsite system that we can authenticate against and allow people into. And so this is sort of a demonstration of just how we can do this. In this instance, we're going to create an enclave where we'll stand one up in real time. And so we're going to generate a new one. So this is maybe for a demonstration in this case, but it could be for a project that we're working with some counterparty that we want to communicate documents to. We're going to create this one group here called demo. And then we're going to actually want to create the resources that people are going to authenticate against and connect into. And this is real-time, actual single-tenant virtual machines that are being created across multiple cloud providers. So this is a long list of geographic locations, so we can deploy across 150 different data centers. And this is actually going to start building. So the process takes about 15 minutes to spin up this infrastructure. Depends upon the cloud provider that's being used. While the system is being built, you can also add other systems in. So that entry point here actually allows someone from the outside public internet access to the inside that you can authenticate through. That's sort of the portal through that cloaked network. These things change over time. And then we're going to create an exit point so you can actually route traffic back out into the public internet. You can choose not to do that if you don't want people to be able to exfiltrate data at the same time. And then in this example is our messaging server. This is ultimately against what people are going to then use their credentials to log into. The next step is going to be to add users into the system and then give them different access privileges. So in this case, it's done through an email invitation where we add them to that enclave. In this case, I'm adding myself. And then we're going to add one more person. This is the counterparty I want to talk to. And then we're specifying is whether or not you have an admin privileges or just basic user privileges. So we tried to make this pretty simple for companies to adopt. You can also import just LDAP user lists and Active Directory to integrate into these. So the next part of this demonstration is the really unremarkable part where we demonstrate that something doesn't work. And that's what's sort of cool about this. So let's say someone phishes a credential, is trying to abuse their credentials or somehow stolen a token. And they're trying to access that messaging server. And what you're seeing here is that the DNS router is failing to route traffic through to our messaging server we just created, right? There's nothing to hit against. We're going to authenticate this endpoint, though, and in this moment be told, all right, you're allowed to use the system. This is the entry point in this moment that does exist that you can connect into. And once we've established that one-time connection through, the messaging server will load and will allow us to actually connect and access those resources. because the virtual machines underlying this infrastructure change over time, while we've granted, here you go, so now we're in. So while we've granted this endpoint in this one moment knowledge about where that network is, an hour or 2 hours later, that knowledge will become useless. That IP address is no longer associated with the organization, which means that doing a targeted attack becomes kind of an irrelevant point for your organizations, because the time and investment that adversaries make, they're going to have to refresh that exercise every couple of hours. So the question is, how are we doing this? The cloaking network itself is using virtual machines that are spun up across all 7 major public cloud providers. And those are creating civilian traffic that look innocuous and the same as if you were going to Amazon to go buy something or to Facebook or Twitter. Once you're granted that access, we give you the entry point in that moment. You can gain access to that servers or these resources that are living inside. These can be applications you're deploying. They can also be things like critical infrastructure, IoT devices, anything that really speaks IP. And then if you want to, you can allow exit points also into the network that allow traffic to go out. You might want to turn that off if you want to have to do analysis. So if you've got a data set at a bank, someone needs to go through, log in, do their analysis, but you don't want them to be able to steal the data at the same time. They can do the work, you cut off the entry point, and then they're able to exfiltrate that information. Worst case, they'll take pictures with their cameras. You can't protect against everything. So when we're talking about the 7 major public cloud providers, we've integrated with these folks so far. You'll also notice that we do on-prem solutions with OpenStack and VMware. So if people have on-prem infrastructure, they don't want to have their data be leaving, we allow people to have that level of control. So again, back to the basic principles of why are we doing this? How does this fit into the authentication model? It's that most attacks have to go downstream, and this is what's known as the cyber kill chain. Your adversary is either going to be a criminal who's trying to make money, or a state-sponsored actor who is there for an operational mission. If they're spending all their time trying to re-find your network, to re-authenticate against it, to then break into it again, but they keep losing that traction, right? They're going to start losing money on you as a target. So they'll go against someone else. If it's a state-level actor, then they have a time frame they have to operate within, and then they can send someone to your facility. But this is a totally different target profile we're talking about. And so it's that idea that an adversary in a traditional authentication model is spending their time to study the network, construct the attack they want to use, and then they can deploy it, at which point the network becomes breached. By constantly refreshing the locations of it, the adversary can never move out of that study phase. Fundamental point being that, well, the internet was built to be hyper-connected. It was not built to be secure, and this is allowing you guys to do that. Any questions? Terrific. Thank you very much. Appreciate it.
Great. I'm Prakash Naresan, co-founder and CTO of Trusted Key, and today I'm going to talk about strengthening trust with the secure digital identity platform. Okay. So if ever you've tried to open a bank account, either online or on the phone, you know it's not a convenient experience, it's not a secure experience, it's not a trustworthy experience. Usually the flow goes something like this. You call up the call center. As a customer, you say, I want to open an account. They say, great. Let's get all your information, like your name, your address, your date of birth, your social security number, place of work, where you've lived in the past, all of that. And whether it takes you 10 minutes, 15 minutes, 20 minutes or more to provide all that information, you don't actually know where that information is going, who might have access to it. And at the end of the day, even when you're done with the process, the enterprise is still not satisfied with the KYC results, and they still might need you to come into the branch and verify your identity at a later point in time, right? And if you're doing it online, it's not much better either. It's typically a 7 or more step process where you have to accept terms and conditions, manually enter all kinds of different information, create a username and password that you're just going to forget and be a target of attack, provide additional information, choose security questions, choose an MFA device, and finally, you might have an account. So it takes forever, customers are frustrated, costs a lot of money, and the drop-off rates are significant, right? So what customers, both consumers and enterprises, want is really a much more streamlined experience. You call up a call center, say, I want to open an account, and the call center person just asks you for one piece of information, which is your identifier, and then can send you a request to share all your pieces of identity that you want to share to open this account, and you can securely share that, and your account is open. That's the experience people are trying to get to. And same in the digital flow, where you accept terms and conditions, provide a handle, you get a request, you can confirm that as user consent, and your information is shared, right? Easy, under 5 minutes, cost effective, and low drop-off rates. So that's the solution that Trusted Key is trying to provide. I'll show you a quick demo. So Trusted Key provides a secure digital identity platform consisting of a identity wallet on your mobile device, a set of back-end cloud services, and all backed by a permissioned blockchain. Okay? So this is our reference implementation of an identity wallet. We also provide the same functionality as an SDK that enterprise customers can integrate into their own app, so they will have a branded experience that's theirs and not the Trusted Key experience. So this is already in the App Store on iOS and Android. When you first open the wallet, you know that it's always protected with your biometrics or a PIN. And the security credentials, the key pair, are created and secured in the Secure Enclave, the crypto processor on iOS and Android, in a way that the private key will never come out. So it's really hardware-level security for all the operations. Once you are in the wallet, you can see that I have onboarded various aspects of my identity, and I'll talk about a few of them. The couple that are most important right now are your email address, so you verify that with a one-time email that we send you, and your driver's license. And there are many providers out there that provide driver's license verification. We have integrations with multiple of them. And this is the driver's license for our product manager. You can see all the various information. I think the process to create this, you've probably seen. You take a picture of the front and back. They put it through machine learning-based checks to make sure the document is genuine, not tampered with, extract the information, then do a selfie that does liveness detection, takes an image, matches that to the image on your driver's license. And if everything passes, we take that information, we tokenize it into digitally signed claims. So each piece of information, like your name, address, date of birth, is a separate claim that's specifically assigned to this user, registered on the blockchain, but there's no PII on the blockchain, just a registry of what was issued, at what point, by whom, to whom, right? And everything ends up in your digital wallet. Great, so what can you actually do with this information now that you have it? So if you were in that situation of wanting to open a bank account, here we mocked up a credit union site. As a user, you come and say, I want to open an account, and verify my identity using Trusted Key. And all the user has to do is type in that email address that they had registered. And that's their unique handle that we know of. Because we know that handle, we send them a notification that shows up on their phone. They use their Touch ID to open the wallet, inspect the request, from whom it's coming, exactly what information is being requested, even match the code here with the code in their request to make sure it's the same request. And once the user agrees to share this information with user consent, the information is packaged up from their mobile wallet back to the requester, and our APIs will check behind the scenes that everything is correct on the blockchain. Nothing's changed, nothing's been revoked. All of that state is managed on the blockchain. Right, so really a very streamlined account opening process, providing convenience and security and trustworthiness. So you see here, the bank can then run any further checks they want, AML checks, credit checks, before they open the account. But once the account is open, the username is that email address, and there are no passwords in our system. It's all cryptographic authentication. The APIs that the bank, in this case, integrates with, just OAuth and OpenID Connect. So, in fact, I can just quickly show you. If you log out of this account, log back in, the process is very similar. Type in your email address, and a notification shows up. It's really multi-factor authentication because you have something, you have your device, and something you are or know, your thumbprint or your PIN. Inspect the request, say yes, and the OpenID Connect request completes, and you're logged in. Right, so that's the platform we are providing. So all this, let me switch back to the slides, is built using the Trusted Key platform. It's live. It's been live for about a quarter. You can go to developer.trustedkey.com, find all the information. As I mentioned, we provide both the identity wallet on the iOS and Android app stores, as well as an SDK with which customers can build a similar wallet, right? And in the back end, we provide a set of APIs, the claims issuance API, through which all those different types of claims are issued by different issuers, and I'll show you more examples in a bit. The claims verification API that was used by the credit union to retrieve the claims, the authentication APIs for login, and even transaction authorization for step-up authentication or protecting credit card transactions or whatever customers might want to do. As I mentioned, we integrate with a set of third parties for identity proofing, and customers can choose which provider they want for that. We provide the admin portals for API provisioning, user management, consoles, and everything is backed by a permissioned blockchain that's based on Ethereum, but it's a permissioned proof of authority version of Ethereum. Okay. We're working with customers in finance, health, education, government on various scenarios. So let me actually switch back, show you some examples without brand names of what we're working on. So here, one of our customers is issuing digital diplomas in education. So if you complete a degree, you'll get one in your wallet. Another customer we're working with to provide credit scores in your wallet that you can then share to open accounts or make purchases. And finally, in healthcare, we're working with a consortium of parties that want to have a single identity wallet where you can have your identity, have your health insurance card, and then use it across different networks to check into a doctor's office or a hospital, share your identity information and your health insurance card, get a prescription, share that with a pharmacy, and get that. Okay? So those are some examples of customers we're currently working with. And really the goal is to build a network where the user has one identity that they control on their mobile device, secured by their biometrics, backed by a blockchain, and any number of issuing parties that are providing them claims about what that issuing party knows about them, whether it's a university, a government, a employer, a bank, or a credit rating agency. The user has those claims. They can share it with whichever relying party they're wanting to share it with. If they're applying for a job, they can share their driver's license, their educational credentials. They're trying to open a bank account, they can share their driver's license, maybe their credit rating. All of that secured with a permission blockchain in the back and a set of APIs that are cloud services. Okay? We're working with a number of customers in healthcare, finance, education, as I mentioned, and also some of the leading system integrators who are now taking this to their customers worldwide. And we would love to work with you on some of these projects as well. So thank you. We have 15 seconds for questions. Yes?
What's the governance model
on the blockchain? Yeah, so that's a great question. Currently, we are inviting partners, significant partners, to join in the administration of that blockchain. If you want to do that, that's great. If you don't care about it, that's great as well. You can just subscribe to the APIs. Okay, great. And we can follow up offline. So.
Alrighty, thank you, Prakash, and that will be the conclusion of our authorization demos.